In the previous video, we introduced the idea of the aldol reaction, and we saw what would happen if you tried to mix together two aldehydes that were exactly the same and perform an aldol reaction. And we said that that was a synthetically very useful reaction. But it raised the question of what happened if you had two different aldehydes that were involved in the reaction. And if we did, we would have what's called a mixed aldol reaction. Okay, so this is what happens when we have two different aldehydes reacting. So let's say we started off with acetaldehyde plus propanol. Okay, and if we were to react these together in the presence of base, okay, we would expect that there would be deprotonation and then attack on a carbonyl. But what would be getting deprotonated and which carbonyl would be attacked? I mean, for example, one thing that could happen is that one molecule of the acetaldehyde could get deprotonated and then attack another molecule of acetaldehyde. Okay, giving the product that we saw in the previous case. Okay, that's one possibility. Another possibility would be we could have two of the propanals reacting together. Okay, in that case, we wind up with a product that looks like this. Okay. But then there's also the possibility that the two molecules could react with one another, but there's nothing to say that one would act as the thing that gets deprotonated, or if it would act as the thing that's being attacked. There's two different possible ways that the reaction could occur. Either you could have the acetaldehyde getting deprotonated and attacking the propanal, giving a product like this. Or we could have had the propanal getting deprotonated, giving us a product that looks like this. Okay, and the question is, well, what do we do about this? Is it possible for us to control this reaction? And it turns out that there are some strategies that we can try. Okay, the first strategy that we can try out involves making sure that we use an aldehyde that doesn't have alpha hydrogens. Obviously, one of the aldehydes has to have alpha hydrogens. But if the other one does not, that means it's impossible for it to undergo this aldol reaction as the thing that gets deprotonated. Okay, so consider the case where we have acetaldehyde again. But this time we react it with benzaldehyde. Okay, so in this case, benzaldehyde has no alpha protons, which means it can't be deprotonated. Okay, so that means the only thing here that's getting deprotonated is going to be the acetaldehyde. So in the presence of base, we would expect to see a product that looks something like this. Oops, not like that. Okay, more like this. Okay, and we actually do see a bit of this forming, but this still has the problem that the carbonyl compound could still potentially react with itself. But that's okay, there's a strategy for dealing with that too. that strategy is to preform the enolates. Okay, what I mean by that is we can take the compound that we're interested in deprotonating, and before we add any of the other aldehyde, we can react this with a strong base like LDA. Okay, so that would preform the enolates, which could then go on to react with whatever the aldehyde is. But we have to be careful with this method, though. We can't just take the aldehyde and add LDA to it. There's kind of a procedure that we need to follow. And typically what we'll do is we'll start off with a flask, and to that flask we'll add a solvent as well as the LDA. Okay, so we have a solution that is consisting only of this very strong base. And then what we do is we drip in the aldehyde. Okay, and the idea is that the moment that that aldehyde hits the solution with the base in it, it immediately gets deprotonated. And because we're only adding very small amounts of the aldehyde at a time, there's no opportunity for it to react with other molecules of aldehyde that have not been deprotonated. So if we do it like this, we can actually generate the enolates completely first. Okay, and then once we've generated the enolates, then we can add whatever aldehyde that we want to add, but we would still want to use an aldehyde that has no alpha protons, ideally. But that's not always going to be the case. Sometimes you're going to have alpha protons. In those cases, you try to run the reactions at very, very low temperatures. And sometimes we have some good luck with it, sometimes we don't. It all depends upon what else is on the molecule.